Well, this is the second part of section 4.7, and it should be shorter than the other one, because those graphs took quite a while to do. So in this next example, this is where they're going to give you the transformations, and then they want you to write the equation. So we don't have to do any graphing, but we might do a little graphing to check it perhaps on the calculator. So on this first one, we've got our parent function 0.2 to the x, and first of all, it's translated 2 units right. So when you're doing this, because f of x is our first one, we need to label our transformed function something else. So I'm going to do g of x. And also, you can do this in steps, and so we'll just see what we got here. So we're going to translate it 2 units to the right. So since that's back and forth, that's going to affect the x. So I need to put my change up here with the x. And if it's going back and forth, it's opposite in the direction it's going. So if it's going to the right, it's actually going to be minus 2. So we'll have that. And then it's compressed vertically. So if it's a vertical compression, that's out in front of the function. And that's a factor of a third. So we don't have to worry about flipping it or anything. It's very straightforward. I might put some parentheses around here. And then it's reflected across the x-axis. So that, when you reflect over the x, also the negative just goes out to the front. So there's a negative out front. So let me write it a little bit better so you can see everything. Negative 1/3, 0.2. We could write it like this. And then you can check it on a calculator to make sure it looks like it's doing what it should. Because sometimes you might wonder, well, did I do it right? So I'm going to type in the original one so I know what the parent looks like. Raised to the x. And then on my next one I'm going to type in. So I've got negative. The 1/3, you do need to put that in parentheses. If you don't, you're going to get the wrong thing. Times, and then 0.2 raised to, and also the x minus 2 has to be in parentheses. So it's possible if you don't type it in correctly, your check might be incorrect, and you actually could have the correct equation. Okay, let's zoom 6. Okay, well, it definitely got reflected over the x-axis. I can see that. It's a little hard to tell if it got compressed vertically. And it looks like it did indeed go to the right. Okay. I'm going to say it looks reasonable enough. Let's do the next one. So this time, we're doing natural log. Oh, and I've got I added a little note there, stretch it horizontally first. So f of x equals natural log of x is our parent. I left a little space there. It's going to, so g of x will be the transformed equation. We're going to go 1 unit left, so that's left and right. That means it's going to go with the x and in the opposite. So if it's going left, it's actually going to be adding 1 to the x only, so you need parentheses. Oh, and it said to stretch it horizontally first. I'm curious to see. I'm going to try it without stretching it horizontally first and then do it the other way and see what happens. Okay, so we translated 1 unit left. Then we're going to go 3 units up. So that's adding 3. That one also is straightforward. You just tack it on to the end in the same direction, as same sign as the direction. And then horizontally stretched. So horizontal stretch is the tricky one. For one thing, it's with the x here. And for another thing, it is the reciprocal. So if it's a stretch by 5, it's actually 1/5 goes in there. So I'm going to have 1/5. If I do it the other way, I'll call that h of x. If I do it in a different order, sometimes the order matters. So if I stretch it horizontally first, that means I'm going to have natural log of 1/5 x. Yeah, I don't think it really matters. And then I'm going to go 1 unit left, so that's plus 1, still inside the parenthesis with the x, and then 3 units up. Okay. And this one, because it's a little, I would definitely check this one on the calculator, because it's tricky. So we'll do natural log of x, and then natural log, and you have to be careful when you type it in. So the 1/5 x, you should type that in as 1 divided by 5, close the parenthesis, then do the x, plus 1, and then you have to close that parenthesis, and then plus 3. Okay, I can see it went left. Wow. These are a little hard to interpret. It looks like it went left a whole bunch instead of just left one unit. But the thing is, it got stretched horizontally also. That's why it's way over here at negative 1, 2, 3, 4, 5. Because the x's get multiplied by 5. That's why it's way out here. And then you could see it kind of went, you could definitely see it went up. So it's reasonable, I think. I don't sound very convincing, do I? I just want to think about it carefully and make sure it makes sense. Okay, here's one you could try on your own. F of x is log of x, that's base 10. It's so g of x, this one's nice. This one's straightforward. If it's translated 3 units left, we know to put that's inside with the x, and its left is going to be plus 3. And then it's stretched vertically by a factor of 2. So vertical stretches are very straightforward. You just multiply the factor out front. So that's one that very straightforward. Don't have to really worry about that one too much. Next. Oh, and that is all we had on those. I was going to look in the book here. Okay. Great. So this is our last one. This has to do with when you learn something, over time you forget it, a certain percentage of it, sadly. And that's very true. Unless you keep doing things over and over. That's why with math, if we keep doing the quadratic formula, or if you keep factoring over and over again, it's going to stick with you better, like over a longer time than it will if you just do it once. That's why we have homework, so you can practice, so you can remember things. Because if you don't practice it, you're going to have a small chance of remembering it. In any case, a group of students retake the written portion of a driver's test after several months without reviewing the material. A model used by psychologists describes the retention of the material by this function. A of t equals 85 minus 15 log of t plus 1. Where a is the average score, so here's your score, at time t. T is the time. And that t is in months. Describe how the model is transformed from its parent function. Okay, so we'll do that first. So first you have to identify the parent. I'll call it p of t for parent. And you just look, and hopefully you notice there's this logarithm here. So that's going to be the parent function. And it's just going to be, the base is 10, so it's just log, the common log of just the variable t. So your parent function is simple. You don't want all the other stuff. So now, right away I notice the t plus 1. So that's inside the parenthesis. That means it's going to be a horizontal shift in the opposite direction. So it's a shift of left 1 unit. So it's going to go left 1 unit. Okay. Then there's a 15 outside multiplied in front of the log. That's going to be a vertical stretch by a factor of 15. There's also a negative out in front. Well, the negative is out in front. That's a reflection over the x-axis. If you have forgotten that, you need to review it and remember it again. And then there's this 85 out here. And it's actually being added because you could think of it as a plus here, Or another way to think about this is if you use the commutative property and you rewrote a of t in a different order, and you left the negative 15 log of t plus 1 in front and then moved the 85, like switch the order, you would have this, because the sign in front of a term goes with that term. So this minus, this negative, goes with this whole term, and the positive goes with the 85. Then when you write it over here, you can see it more clearly that the 85 means it's a horizontal shift up 85. So it's going to go up 85 units. And the units in this case are the units of the y, which is the score. Great, so there's the transformation. And now it says use the model to predict the number of months when the average score falls below 70. So the average score, this is the average score, it equals this whole thing. So this whole thing is the average score. We want to know when that average score is below 70, in other words, less than 70. So, in fact, I can do it right here. Just take advantage of this. Oh, nice little eraser too. Perfect. So we want to know when this whole average is less than 70. Kind of move this over so we block that off. And now we're going to solve, just like we always would. So we're solving a logarithm. First of all, just like in algebra, what you want to undo first is you want to undo this 85 by subtracting 85. So that's negative 15. Oh, I wrote 18. Why did I do that? That is really weird. Okay. Negative 15 greater than negative 15 log of t plus 1, because that's gone. And then we need to get rid of the negative 15. This is a very nice problem, isn't it? So that's going to be 1 on the left. Oh! Guess what? I just divided by a negative. Do you remember what happens when you divide both sides by a negative and you have a, one of these symbols? You have to flip that thing. That's something from way back in Algebra 1. And then we've got log of t plus 1. Now we have a logarithmic equation, and we undo logarithms with exponentials. The base of this logarithm is 10, so we're going to make so that they are exponentials with base 10. So 10 to the 1 is 10. That's out of there. T plus 1. And we're almost done. We can subtract 1 from both sides and keep everything lined up. So we're going to have 9 is less than t. Or in other words, t is greater than 9. T is in months, so after 9 months, you can figure that predict that your average score is going to fall below 70. Aren't those fun? Solving is always fun. I always like it. I hope you guys do too. That's it.